Hi. This video is about the things to do for creating the model of a loft, but not by applying loft process, sweep process. Well, this is the model of, yes, a loft, kind of loft. If the cross section of the prism is changing in size or in shape from one end to its other end, then it is called loft. And normally the model of a loft is created using this tool of the software. Okay, in almost all the solid model environments, yes, can find such an option. If the prism is not a right prism with the same cross section in shape and size, then apply not extrusion process, but if the cross section is constant in size and also in shape, but the prism is not straight, then can create the model of it using sweep facility. But if the cross section is changing in shape and in size then it is created applying loft process, and the result in short is called loft. But here this is a special case. It is loft, but in loft process need to select enough number of cross sections from the beginning to the end of the object, and then at each cross section draw the profile and then apply the loft process. But if the loft is symmetric and loft cross section, the shape of the cross section, geometry of the cross section is the same. It is size is changing, but the geometry is the same. At any cross section of this object, the profile is a rectangle. Here at the beginning it is in minimum size, at the end maximum size. You see it is diverging in this direction or opposite direction, converging. If it is the case, cross section, the geometry of the cross section from the beginning to the end of the prism is the same, but size is to change or changing, then sweep process can be applied. Applying the process, there is a trick. Now this video record is about such a case, and then underlining the tricky stage. Using this facility at a shorter time, only at one cross section having the profile at the beginning or at the end can create the model of the loft. Shorter time, little effort. Okay, so see how it is created. It's going to be a new file in the end to its content. So I selected unit system, part creation template, and then clicked on create button. Model creation starts from sketching stage, so clicked on 2D sketch button. Take a sketch right, indicating one of the coordinate planes to have the sketch plane as coincided. For the first coming sketch, it is the thing to do, you know this. And then, in my demo, yes, there will be two lines at that stage to have, one of them straight. Okay, start from here arbitrarily and then create the line. Okay, horizontal oriented or vertical. Well, the orientation and sketch mode not so important. Dimensional constraint, the length of this line depends on the shortest distance between the inlet and exit of the loft. In this example, it is 2 meters, 2000. And then, well, if you have Excel data, transferring the data to Inventor, have the curve. If there is no such a data, then mark the points, locate them with respect to each other, and then join the points with a continuous line. Okay, say that this is the first point, this is the second point, etc. First, arbitrarily mark. Okay. Enough number of points. It depends on the precision of the studying in fitting the curve onto the points. Well, what is the precision? Accordingly, select enough number of points. And then, of course, well, if there were Excel data, then I would have the necessary curve just almost immediately in few seconds, clicking on this insertion button. You know this from the previous settings. But here, patiently, well, locate those points, knowing the distance between each other relative to a certain reference or relative to each other. Well, the first point from the straight line is 1000 millimeter away. Okay, and the same point from the starting point is in alignment 0 millimeters away. Well, the first point is okay, and then the second point. With respect to the first point, the distance in the horizontal direction for this orientation can say horizontal, say that 200. Okay. The distance from the reference, say this horizontal line, to the second point, say that 1000, I don't know, can say 100. Okay. Second point from the third point from the second, I'm going to locate the points regularly, say using the same distance in the horizontal direction. Okay. But vertical direction, yes, say that 1260. Third point, and then so on, so forth. Well, this point, following point, is away from the reference. It is coordinate is 1300. Or a little bit more, say that 340. Okay, and distance from here to there is 200. Yes, well, this stage is a time-consuming stage. Since in this example I said that there is no Excel data. If there were Excel data, then I would find the curve in few seconds available in sketch mode to continue on the rest. And then this point from here to there, say that 140 millimeters away, or just 1500, let's say. Okay, and distance from here to there, 200. Although I marked more points, but say since I am using 200, 200, 200, can have maximum, I think 2000 divided by 210 points. So 1, 2, 3, 4, 5. Okay, and then 5 more. No need to have the others. Delete this one. 1, 2, 3, 4, 5. One more, delete. Okay, these are the other points to have. Dimensional constraint. Distance from here to there, again 200. Okay. From here to there it is 200. From here to there 200. 200. One more point I think can be used, because 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, one more point is needed. So create one more point. Okay. Arbitrarily first, and distance from the 9th to the 10th is 200. Okay, and then this point relative to the horizontal line, 1500, then let's say 60. This point from this reference 1000, I don't know, say 500 and 1600, and then this one 1680. The next point 1740. Okay, and this point 1850. Well, I think I use the same number. Say that 90, 1900. Oh no, well, it is the wrong point. 1860, but for this one, relative to here, distance, dimensional constraint, from this point to that point, distance is 1940. Okay, is there any other? That's all, I think. Well, little bit without knowing the functional relationship between x and y values, I input the other value, say in the horizontal direction regularly increasing the distance 200 by 200, but in the vertical direction little bit arbitrarily, and then join the points using spline tool, fit the curve. This point snap cursor, this point snap cursor, snap, snap, snap. The next point, this point, this, and I think this is the last. So clicked on OK button. Yes. Finish the sketching stage, and then, well, the profile at the beginning of the loft, it is my consideration these 2 points, the starting point of this path and this guide, are in the same plane. and in the same plane well, have the profile of the loft at its inlet. So well, to be able to draw the profile, I'm going to use this tool, work plane facility, normal to occur at a point. I selected this option, normal to occur at a point. This is the curve, and this is the point to have the work plane as normal. Yes, this is the core region of the work plane, but it is unlimited, you know. I'm going to use this work plane to draw the profile. Take a sketch, right on it, right click, new sketch, and in sketch mode, draw the profile of the loft at the inlet cross section. To be able to have the profile, okay, the boundary of the profile is to pass through this point, okay. I'm going to apply projection process and have the projection of this terminal point. And then create a rectangle, okay, arbitrarily. And then dimensional constraint. From this boundary of the rectangle to the projection of the starting point of this curve is equal to 0. From that point to the upper boundary distance, say that is equal to, I don't know, say that for instance, okay, 600. Height of the profile at this cross section is 1200. Okay, and from here to there distance I set 1000 between this guiding line and this say curved line at the inlet cross section is 1000. So well, to be able to have the profile symmetric at the cross section, well, distance from here to the other boundary of the rectangle must be 1000 times 2, 2000. Okay, finish the sketching stage. And then what I have? I have two different sketches. One sketch, I have this guideline and this path. The other sketch plane is perpendicular to the plane of the first sketch. I have a rectangle. Here in this example, since the cross section of the loft is rectangular in shape, that's why it is a rectangle. And the cross section, inlet cross section, the profile is 2000 by 1000. 2000 by 1200 in size. The rest is achieved by the sweep process. Okay, start the process. Well, this is the profile. Since it is the only closed region, then Inventor automatically sensed that it is so. Well, selected that profile. No need to indicate it. And then here, yes, there is a trick in the property, sweep property table or sweep creation dialog box. Well, profile, yes, automatically sensed. Select curve, say to indicate the path. This is the display to click. It is going to be automatically clicked by the software in the order. If there is a blue shading as along the boundary of such a monitor, then this means it has been toggled on. So well, here path is not this curve. Path is this straight line indicated. Now Inventor, you see, well, using it is default configuration, automatically selected this orientation, this behavior option. So well, saying that our profile just repeated along this path. Since the profile is rectangle and the path which I indicated is a straight path, you see the created sweep will be it it is being simulated, it will be, if I say OK, a rectangular prism. Actually, if my purpose were rectangular prism creation, then I would apply extrusion process. The trick is that if the sweep is to change its cross section from the inlet to exit, so well actually such an object, its cross section is changing in size, is called loft. But here, since the loft has a symmetry and the shape of the cross section is not changing from the beginning to the end, it is a rectangle. I said at the beginning, as I said at the beginning of this classwork, well, to be able to create such a loft, sweep process can be applied. But this is the trick. Well, select not this orientation, not that orientation, but guide option. And this curved line is the guide. After clicking on this, yes, guide indication display is now toggled on, and then indicate this curved line guide. And then you see the magic. Inventor considering the guide, okay, well, change the size from the beginning to the end, and then say OK. Here, one more thing, sorry, I forgot to indicate it. Turn back to here. Sweep icon you see has appeared in the list of the icons at the browser. Right click the mouse. Whenever you need to edit the already created one, right click the mouse when the cursor is on that icon. And then from the list, it will disappear. It will appear in the screen. Select edit feature option. Here the thing to highlight, which I forgot to indicate it, is that profile scaling. You see, profile scaling, if you select the first one, then in both of the direction the size will change. Okay? Well, program will gather the data from the path to the guide distance, and that value, this changing in the x direction, is also used relative to the height of the cross section, of course. Inventor at the background using its code, subroutine, subprogram, use the proportionality and then change the size of the cross section in the vertical direction as well. But if this is selected, see the changing. Only in the horizontal direction you see cross section changing, but vertical direction constant. If this is selected, yes, well, the guide will not be followed. Select this one, because here in this example, well, the guide is to be followed not only in one direction, in both of the direction. Yes, this is a complementary thing and important. Clicked on OK. And then here's the strange object. Okay? It is by definition a loft, but you see, since the cross section is the same in shape, only size changing, well, use sweep process, applied sweep creation, use sweep creation tool, and via which save time. Otherwise, I will draw for fitting the body onto 10 cross sections. I use 10 points, 10 different cross sections. I will draw the profile at 10 successive cross sections, and the time needed would be relatively too much. Okay, if it is just a loft to connect one channel to the other, then empty the inside. Shell process in this demo, I'm going to empty the inside. Well, the wall thickness, say that 5 millimeters into the box, 5, and then remove phase button on. Well, there is a problem in my computer. Yes, now it's okay. Indicate this surface. If the shell will be a blind shell, one side surface, to say that it is going to be emptied starting from the surface. But if it is truly extending shell, open to the outside at both of its ends, then indicate the other end as well. But of course, if along the guide there is a discontinuity relative to the written thickness value, then of course this means mathematically it is impossible to empty the inside. Then in that case, well, it is to be changed. Try saying OK. And then yes, achieved. You see, it's a thin walled object, and the wall thickness with respect to all the surfaces is the same. If there were no shell facility, then emptying the inside of such a strange prism would take infinite number of years. Okay, then I think this is clear enough. It is made of which kind of material? Say that it is made of stainless steel. Right click, assign. Now it is the solid model of the loft, but you see, created this loft applying sweep process. Okay, finish the classwork. My dear students, say that, stay healthy, bye bye. Well, after talking about loft, sweep, and one more time revolve process, now in the order for Mac 113 students, it is the time to focus the attention to dimensioning part. Okay, next class is about dimensioning format. See you then. Bye bye.